Hey guys, it's Mr. Kilburn, and we're going to go through a couple examples here of quotient rule and product rule. I realize that it can be frustrating with the algebra cleanup and just with the different exponent rules that you've known in the past, but putting all these together, they get kind of wonky. It can be frustrating. So we're not going to do chain rule Monday, Tuesday. We're going to kick that to after break, and I want to make sure that your skills in working with product rule and quotient rule are fluent and you're happy with it. Just to kind of get in that mental space where, this stuff can be challenging, but you can do it. So the only way to do that really is to do extra practice, build your confidence, and that's what we're going to do, okay? Alrighty, so I'm up in the third floor here of the math studio, and so it's nice and quiet. Andrew's got her friend down, staying overnight. Avery's getting her hair done, so it's kind of a little respite area. Okay, here we go. So it says, suppose that the amount of air in a balloon at any given time is given by V of t equals 6 times the cube root of t all over 4t plus 1. And they want us to determine if the balloon is being filled with air or being drained of air at t equals 8. All right? So you know that when you have a function and you graph it and you take the derivative will tell us the slope of a tangent line at any given point. So if you just had some parabola, you know that if you know the derivative of that parabola, you can determine the slope of the tangent at any given point. Okay, the slope could be positive, it could be negative, it could be 0, and anywhere in between, right? Well, what's the derivative of this function going to tell us with respect to the volume of the balloon at t equals 8? All right, so I want you to pause the video and just type in, what do you think our answer is going to tell us? How are we going to know by looking at our answer at v prime of t, or sorry, v prime of 8, whether or not the balloon's being filled with air or emptied of air? Okay, guys, so this function actually looks like this. There's a vertical asymptote at -1/4. It comes back up here and does something like this, and then it does something like this. Okay, so let's just suppose 8 is right there. Clearly, if you were to take the slope of the tangent line at that point, it's going to have a very, 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 very slight negative slope, but negative nonetheless. So if the derivative at v prime of 8 is negative, must be the balloon is being deflated at that point. All right, so there's kind of the punchline. Now we're going to prove it. Okay, here we go. So let's do this. So let me rewrite this. V of t equals 6 times the cube root of t all over 4t plus 1. All right, so one thing I have not encouraged you to do yet, that maybe it would be helpful if you did, is off to the side, just write down what f prime and g prime happen to be. Okay, and you can even write down the whole quotient rule if you want. That's a little... Okay, so I'm going to identify what is f prime, what is g prime. That way when I'm going to fill in for quotient rule, I'm not really taking the derivative at that point, I'm just plugging in. Okay, so 6t to the 1/3. All right, so again, we know that's f and that's g. So 6t to the 1/3, just a straight power rule, excuse me. So 6 times 1/3 is 2 t, and then subtract 1 from the 1/3. So I'm really subtracting like 3/3. So that becomes -2/3. And the derivative of 4t plus 1 is simply 4. Okay, so now let's plug in here. Okay, so f prime. So I've got 2t to the -2/3 times g, which is 4t plus 1, minus f is 6t to the 1/3, and the derivative of, just g prime is simply 4, all over 4t plus 1 squared. Okay, and this is, we're figuring out v prime of t. Okay. Okay, so now we've got some multiplying to do. Okay, so first I'm going to multiply right here. Okay, 2 times 4 is 8. T to the 2/3 times t. Well, that's like saying t to the 2/3 and t to the 3/3. So -2/3 and a +3/3 gives you a +1/3. And 2t to the negative 2/3 times 1 is simply 2t to the negative 2/3. Okay, minus, well, this multiplying here is pretty easy. I'm simply going to get 24t to the 1/3 all over 4t plus 1 squared. Okay, so now I can clean up top a little bit. 8t to the 1/3 minus 24t to the 1/3 is going to give me negative 16t to the 1/3 plus 2t to the negative 2/3 all over 4t plus 1 squared. Okay, now at this point, because we're just substituting in an 8, okay, that's what we're going to figure out, excuse me, at this point is v prime of 8. I could push this down in the denominator spot, or I could simply write it as 2 over t to the 2/3 and leave it up top like that. It's up to you, doesn't really matter. I'm just going to leave it up top for the heck of it, but I'm going to start subbing in an 8 for t. So I've got negative 16 times 8 to the 1/3 plus 2 over, okay, so 8 to the 2/3. What's 8 to the 2/3? What's that mean? Well, that's the cube root of 8 squared. And 8 squared is 64, and the cube root of 64 is 4. So this really gives me 2/4 or 1/2 all over 4 times 8 plus 1 squared. And again, this is v prime of 8. Okay. Alrighty, well, now the cube root of 8 is 2. So I've got negative 16 times 2 plus 1/2 all over 4 times 8 is 32 plus 1 is 31. 32 plus 1, 33. I don't even know what I just said. And 33 squared is 1,089. I did that off to the side. I didn't just do that in my head. So there you go. Okay, so now up top I'm going to have negative 32 plus 1/2 would be negative 31.5 divided by 1,089, which in decimal form is 0.024, something like that. But it's negative. Okay, that's a negative number, meaning our slope is negative, meaning the balloon is actually being deflated at precisely 8 seconds, 8 minutes, whatever it was. Okay? Alrighty, so there is that one. Next, product rule. And I picked this one specifically because, as you can see, our exponents are going to get a little bit wonky, but that's okay. It's the only way we learn how to do this. So the first thing you may want to do is jot down the product rule. F prime G plus F G prime. And again, if you want to isolate or identify what the derivatives are right off the bat, not a bad idea to do that. So here's F, and here's G. Okay, so the derivative of 1 plus x, well, let's identify what that is. Let's write this with an exponent first, okay? Okay, so that's saying the square root of x to the 3rd power, all right? So as a fraction, what do you write? X to the 3/2, okay? So 1 plus x to the 3/2, the derivative of that would be 3/2 x, subtract 1 from 3/2, subtracting 2 over 2, and you get that. So I get 3/2 x to the 1/2 as the derivative of f. Okay, now g prime. So x to the negative 3 is going to be negative 3, x to the negative 4, and I'm going to write this as excuse me, 2 x to the 1/3, negative 2x to the 1/3, like so, okay? So the derivative of that is going to be negative 2/3 x. When I subtract 1 from 3/3, sorry, when I subtract 1 from 1/3 or 3/3 from 1/3, I'm going to get negative 2/3. So you actually get negative 2/3 x to the negative 2/3 as the other part of that derivative of g prime. Okay, so now I've got my derivatives here and here. All right, so let's do the quotient rule. So again, product rule. F prime g plus fg prime. So f prime, 3/2 x to the 1/2. You know, actually, I'm going to write this down here so I have a little more space. Okay. Stop. 3/2 x to the 1/2 times x to the negative 3 minus 2 x to the 1/3 plus 1 plus x to the 3/2 times the derivative, or times g prime rather, negative 3x to the negative 4 minus 2/3 x to the negative 2/3. Okay. Alrighty then. So let's start multiplying and doing our exponent rules in just one step at a time. So I'm going to start here. Okay, 3/2 x to the 1/2 times x to the negative 3. Well, 3/2 times 1 is 3/2. Now x to the 1/2 times x to the negative 3. Well, x to the negative 3 is like saying negative 6 over 2. So 1/2 take away 6 over 2 would be negative 5 over 2. All right. Next, 3/2 times negative 2. The 2's are going to cancel. You're going to be left with negative 3. 1/2 times 1/3. Okay, what's 1/2 times 1/3? Take a second by hand and figure that out. Okay, so some of you are like, what did he just say? What's that mean? Remember this? To get a common denominator, 2 times 3 is 6, 3 times 2 is 6, 1 times 2 is 2, 2 times 3 is 6, 1 times 3 is 3. Okay, so what I'm really doing is 3/6 plus 2/6, and that's going to be 5/6. Okay, plus, so I've got a FOIL over here. All right, so 1 times negative 3, this is a minus here, negative 3x to the negative 4 is simply that. One times negative 2/3 x to the negative 2/3 is negative 2/3 x to the negative 2/3. Okay, next, x to the 3/2 times negative 3x to the negative 4. Okay, so that's going to give me negative x. So 3/2 x to the 3/2 times x to the negative 4. Okay, that's like saying 3/2 times, or adding to it, negative 8/2. So 3/2 and negative 8/2 would be negative 5/2. Okay, so where am I? Negative 3x to negative 5/2. And then lastly, x to the 3/2 times negative 2/3 x to the negative 3/2 is going to be negative 2/3 x to the, so 3/2 and negative 2/3. Okay, so 3/2 and negative 2/3 is like saying 9/6 and 4/6. Okay, well 9/6 take away 4/6 is 5/6. I know, brutal, right? Okay, so let's, do I need those parentheses? I guess I do not. Let me double check, do I need those? No, I'm going to lose them. Okay. Okay, what can we combine here? Hopefully we can combine some stuff. And I don't need this plus sign here. Okay, so I can combine 3 halves x to the 5 halves and negative 3x to the negative 5 halves have same exponent. So 3 halves and negative 3 would be negative 3 halves. Okay, so that goes away and that goes away. What else can I combine? The 5 to the x to the 5/6. Okay, so that is like saying negative 9/3, negative 2/3. Okay, just rewriting this as negative 9/3. Okay, so that becomes the same sign as that, keep the sign. So negative 9/3, negative 2/3 is negative 11/3. X to the 5/6, which gets rid of this, and it gets rid of this. And then I can't combine those, they have different exponents. So this should probably be out front here. And we'll just slap this on the end here for the heck of it. Okay guys, so that, is that y equals, no, there's your y prime. Okay, negative 3x to the negative 4 minus 3 halves x to the negative 5 halves minus 11/3 x to the 5/6 minus 2/3 x to the negative 2/3. Okay, messy? Yep, for sure. I mean, messy. But you just need to stop and one step at a time. When you're foiling, check your exponent rules, etc., and it just takes time. You know, I mean, I do problems like this, and I'll check the answer key and it's wrong, and I got to go back and figure out where my screw up was, and so, you know, this kind of math just kind of takes time, takes practice. Give yourself some grace. You're not going to become experts overnight, all right? But I have faith in you. We're going to do this together. You're doing great. All right, guys. Hope you have a good weekend. Short week next week. Pretty sweet. Thanksgiving break coming up. Looking forward to that. Get some good food, etc. All right, guys. Have a great day. Take care. Bye.